Okay, let's deep dive on the supply chain resiliency. We need a supply chain more resilient. We need to explore the pull system to fight instability and become more resilient. How can we adapt the pull system, the lean system, to become more resilient? We need to develop, or we can develop, a supply chain digital twin model based on the strategic end-to-end mapping that we did to gain more visibility on the performance of all the elements, all the loops of the supply chain, including all the tiers of suppliers we have. We need to install an OBEA or visual management room for visual risk crisis management. We can do this. This is really a kind of war room in times of war. We can think about that this way. And we have to implement a tiered help chain process between all the teams that are acting and managing the supply chain. So this is what we call internally just-in-time with just-in-case features. We will see that it's much better than a traditional system with just-in-case features. So this will explore all the qualities, all the features of the just-in-time Toyota system, creating the flow in all the logistics loop like we saw in all the other capabilities. So we all know that we are living in a VUCA world. Some years ago, since 2010, people started talking about the VUCA world, and it's getting worse nowadays. So we are facing challenges at every turn. A pandemic, a strong recovery after a sharp and deep global recession, a war in Ukraine, dramatic economic sanctions against Russia, mounting inflation in raw materials and components. More than ever, we are living in a VUCA world. VUCA means volatile. The environment demands you to react quickly to ongoing changes that are unpredictable and out of your control. Uncertain. The environment requires you to take actions without certainty. Complex. The environment is dynamic with many interdependencies. And ambiguous, where the environment is unfamiliar, is outside of your expertise, something completely new like the pandemic was, and we don't know what is coming. So we are living in an unprecedented surge in demand, amplified by post-COVID consumption and investment, what we call the whiplash effect. In 2020, we have a drop in demand because the society almost stopped, and now we have an amplification of demand to recover in all the ways. We are also living an unprecedented shortage in supply, amplified by disruption in containerized logistics, semiconductor shortage, energy and raw material inflation, and other problems. So the risk of a shift from a high demand, low supply that we are living now to a low demand, low supply economy is on the horizon, like the 74 Arab-Israel war and subsequent oil crisis. We are not yet there. We are in a high demand, low supply crisis, but this can evolve quickly to a low demand, low supply, especially if inflation increases a lot, like it is already starting to. All the VUCA, volatile, uncertain, complex, ambiguous factors put a high pressure on supply chains in all sectors to keep on time in full and delivery times at acceptable levels and to recover quickly if we have disruption. The capability of being resilient, let's say minimizing disruption and recover quickly, is therefore a major one in current times. As a consequence, companies are facing significant challenges across supply chains in the wake of the crisis, in planning, in sourcing, in production, in warehousing and distribution. Here we make some comments about the main difficulties. In demand planning due to lack of data, demand variability and difficulty forecasting, difficulties in end-to-end monitoring of the supply chain, sole sourcing or using non-substitutable inputs, shortage of critical parts and materials, long lead times, delayed shipments, lack of visibility information on impacted suppliers. In production, sole concentrated production, difficulties in rapidly scaling production up or down, aging physical plant and equipment, difficulties in reconfiguring production lines. In warehousing and distribution, difficulties in balancing stock between warehouses, low inventory, lost sales due to stockouts, risk-prone logistics, difficulties with products being held in ports or across borders, and products with short shelf life being wasted. But there are typical resiliency solutions or measures that we can implement to overcome these difficulties. Some of the most commonly discussed are improving collaboration on forecasting, developing digital twin simulation models for scenario building and scenario decision, categorizing suppliers by risk, dual or multi-sourcing of raw materials, regionalizing or nearshoring the supply chain. And in warehousing and distribution, expanding backup production sites, increasing capacity buffers, nearshoring production, or increasing manufacturing network diversification. To finalize, in warehousing and distribution, increasing inventory buffers of critical products along the supply chain, harmonizing or standardizing products, reducing the SKUs in product portfolio. All these typical solutions can be used to increase resiliency in a traditional push supply chain, but this will have a higher cost. Increasing resiliency in an end-to-end demand-driven and agile supply chain is much less costly and highly effective. This is the comparison we are doing here. So if we look at the several areas of the supply chain, planning, sourcing, production, warehousing and distribution, we can see that for the main types of solutions, the difference between a traditional push resilient system and a new end-to-end pull and agile resiliency. So in terms of forecasting, in a pull system, we use real demand for S and OE. We only use forecasts to set up available capacity, like it was explained in another part of this webinar. And we do simulation models based on Gemba maps and pull principles, and the size of the needed buffers is minimized, contrarily to the traditional system where we have much higher inventories. And in the areas of sourcing, in the pull system we have suppliers engaged in the lean development program. We have joint participation in value chain mapping and analysis. Contrarily, in a traditional system, the cooperation with suppliers is limited, and we have high level of dysfunctional stocks, meaning that we have too much of what we don't need and we have too less of what we need. And we are really not sure what just-in-case buffers we will have to increase, because overall the amount of buffers is so big that we will necessarily increase the costs. In the pool system, all the stocks all across the supply chain are standardized, and the just-in-case buffers are decided based on scenarios that minimize cost and optimize service. So we will see also about regionalizing or nearshoring the supply chain, the difference between a pull and a traditional push system. Nearshoring is explored to the maximum. You can see the Toyota network of suppliers close to the plants, and nowadays in the auto industry this happens a lot. You'll see also suppliers are challenged to implement pull system. This is contrary to the traditional push system. So we will see in terms of dual or multi-sourcing. Dual sourcing is the traditional system. Triple sourcing, where one supplier has 60% of the delivery and two others are supplying 20%, is the preferred solution. In production, we see that we will only invest after exploring all the resource efficiency, like the OE of all the equipments. We plan capacity buffers with a leveling algorithm using rhythm wheels or small batch sequencers and adapting this to the level of demand. So it's a kind of dynamic capacity buffer optimization. So we don't have anything of this in the traditional system. We have high investment in new sites on new lines, high levels of resource waste, Muda. We have limited nearshoring. And in warehousing and distribution, the same thing. Buffers are increased in some percentage for critical parts, but the amount is manageable and is standardized. under the existing or slightly increased capacity. We have limited reduction in product offer due to small amounts of buffers. And we have a partial reduction in SKUs following a VRP program, variety reduction program. All this is much worse in a traditional push system. It is interesting to look at what happened in the benchmark case of Toyota, how Toyota Motor Corporation performed during the previous crisis. So we had in 1974 the global oil crisis. What was the problem? The Arab-Israeli war brought high inflation and material shortage based on the higher prices of the oil. We have high prices and difficulty in obtaining all types of materials and components. Car demand started to fall. Efforts to cut costs were not enough to maintain profitability because of high costs of materials and components and low demand. What was the result for Toyota? Toyota was the first one to react to falling demand, immediately cutting the production orders and the orders in the supply chain, including to suppliers. Production was adapted to demand and all inventories were quickly adjusted, very quickly, in a question of a few weeks. Toyota then, when demand recovered, was the first to restart production when demand recovered. The world saw the superior Toyota operation system, lean, fast and resilient. It was at this time that the term lean was born, with the book, The Machine That Changed the World, that was talking about the Toyota operation system or the Toyota supply chain as a machine that changed the world, making the machines that changed the world, that are the cars. So this was the first demonstration of the superiority of the Toyota supply chain or operation system, of being lean and fast and resilient. To be resilient, you must be fast, you must be quick, and you must be lean. If you are not fast, and if you have a lot of waste, you cannot be resilient, or you can be resilient at a very high cost. What happened in 2011 with the earthquake and tsunami disaster in Tohoku? So we had the earthquake and the tsunami. Almost 500 million people became homeless with distracted houses and cities. Almost 15.5 deaths. We had the Fukushima nuclear disaster. The Toyota production fell immediately, 78%, prompting a very quick inventory adjustment, and a major review of the supply network was performed to embed resiliency. What happened is a business continuity plan was created and perfected in Toyota. So the lean and fast just-in-time system from the global oil crisis was refined and improved with a business continuity plan with just-in-case stocks, standardized just-in-case stocks, but maintaining the just-in-time system of Toyota. It included triple sourcing, 60-20-20, and safety stocks for critical parts. And once again, the speed of recovery was outstanding due to the help provided to suppliers and the agility of the production system. In the next crisis, last year, the semiconductor crisis in 2021, Toyota had no issues because they had the safety buffers for the critical semiconductor parts that were implemented on the business continuity plan of 2011. So this was really the evolution of the just-in-time system to a just-in-time system with a just-in-case feature to fight disruption and to be more resilient. We also need to develop a supply chain digital twin model to gain more visibility and do simulation and use an Obeya room for visual risk and crisis management. So a simulation of the supply chain, like is shown here. We can start with the strategic end-to-end mapping of the supply chain, exploring the pool system solutions like leveling of capacity, compressing lead times, nearshoring, triple suppliers, SKU variety reduction, etc. Identify critical components, equipment, facilities, and transportation routes. Set up inventory and capacity buffers. Simulate several options to reduce inventory costs and capital investment. Use the digital twin model to review the supply chain performance on a monthly basis under the S&OP planning process based on the pool system. And posting everything in a supply chain transformation room in a visual place, physical or virtual room called the obeyer room or the visual room, to perform risk analysis based on crisis evolution scenarios, during crisis to review resiliency roadmaps on a monthly basis, quickly simulate and implement countermeasures, be fast in reacting, reviewing the roadmap implementation performance. And finally, to be resilient, you need to set up a help chain quick reaction process. So all the teams working in the supply chain, they need to be able to quickly escalate and solve difficult problems. Daily management meetings are used to identify wins and losses and quickly move to actions. Set up a TMS tired management system, a help chain, identifying critical attendees based on how the KPI information should cascade, think of inputs and outputs and who is impacted, identify key leadership to disseminate the information from one department to another, align KPIs across all tier levels, separate but interconnect meetings, schedule a separate problem-solving meeting with progress briefly noted at the daily management meeting. To give you an idea, an example of a tiered help chain team meeting, you will see here in supply chain with manufacturing, DC, distribution center, market logistics, supply chain planning, customer experience groups. So all the groups that are working in this supply chain, all the tiers, tier 1, 2, and 3, and 4. You see the help chain from the bottom to the top with the daily meetings at all levels, making the help chain work with a tiered sequenced meetings. And you will see also cross-functional meetings to discuss problems between teams, like the order fulfillment meeting, the demand service meeting weekly, the supply meeting weekly also, making problem solving quick and a flow process to attack and solve the problems very fast. So management must be quick, the physical system must be quick, the information system must be quick. So an agile system end-to-end, driven by demand and with just-in-case measures, is the best system you can have for the best performance and to be very competitive in nowadays that we are living turbulent times. But improvement and Kaizen is a way of life, and this always worked and it will always work for the future.